Hello everyone, my name is Mohammed and today I'll be presenting and demoing the work that I worked with my colleagues for this hackathon, Alex, Marwan, and Hanying. And what we did is we developed a plant disease identifier using deep learning CNN architecture. So the reason why we did this is we wanted to make an app for producers because they have many decisions that they need on their farms or whatever growing operations that they have. And the decisions that they make include inputs to the farms like fertilizer, herbicides, and pesticides. And we should really be caring about how they use these three products because it affects the rest of the world. So, and a lot of the decisions that they make are based on their plant health and characteristics of the plant and how they're growing. So, um, however, being able to quickly identify any issues with their plants can be very challenging, and they often hire consultants and plant specialists as well as labs, which can be very uh, expensive. So our objective was to provide growers with a tool that can let them quickly identify an issue on site with nothing more than their phone camera. So without further ado, I'll demo this before I finish this presentation. Um, so here we have our web application. Of course, this is still version 1.0 and we plan to update this in the near future. We are using these images as tests input for our application, and honestly we just got these from the internet. So like here we took an image of apple rust, here we took like healthy leaves of strawberries, and we're also showing that it can use different like you can have any type of background and it can still identify the the crop. So when we okay, so let's test this out. So let's first do an image of something very easy. So the image I just showed you of the cedar rust. So if I upload that, we can see that we've identified cedar apple rust. And this web app gives you a short description. We use an API. We do a web scraping so that we can find this. If we don't find anything good, we don't show the actual description, but that's basically how this application works. So here we were able to identify cedar apple rust. This is pretty easy because the background is whited out. So we'll try another easy one. Let's say black rot. Black rot is a common apple disease, and it's a big problem in apple orchards. So here we're able to identify black rot. Again, it's pretty easy because the background is pretty uniform. So let's try something a bit more difficult. So here I got an image of strawberry scorch, and it's basically difficult because you have the background. This is a typical image that you would take on the field and see. So we were able to identify leaf scorch, and the model that we made was actually 92% accurate. So we were quite happy with the results. So let's try. So it's not only for identifying disease, so we can identify whether a plant is healthy. And here I'm going to put a field of strawberry leaves, and we upload that, and we see that there's nothing wrong with these leaves, and this is an image that you would normally take on the field, and it tells us that it's healthy. We are able to identify which plant it is, but for some reason we weren't able to just display it due to the lack of time. I guess we could do maybe one more. So not only does it do diseases, but it can show you things like mold. So here you could see we've identified leaf mold, and this is of a tomato plant. We were able to identify it, but again, we didn't have time to display the tomato part, but we are able to identify the tomato. So that's pretty much how this web application works. I'll show you basically how we built it. So we use transfer learning. We use the ResNet model that was trained on ImageNet. This is very good because it's quite a known model, and it's pre-trained, and it's trained on some flowers, and so it's able to identify with background images. We removed the final classification layer and added our own custom layers here. You see we added a couple of linear layers and dropout layers. The dropout layers we added to prevent overfitting, and yeah, this was just to make our model a bit more complex and a bit more accurate, while also reducing overfitting using the dropout layers. We use the Atom optimizer. It's a pretty common optimizer, and we use cross entropy loss, so we actually get a distribution of probabilities that show us what its most likely is, and we just choose the highest probability of what it actually is. So here we trained on a data set of 156,000 images. So actually we trained on about 200,000 images, but we split it into three sets: the training set, validation set, and testing set. The validation set, so we had like a ratio 80-10-10, and the reason why we use the validation set is for the same reason as the dropout. We want to prevent overfitting, so we can monitor how the model is actually doing on a different set of images that it's not being trained on. And here we just trained it on 15 epochs. It's not that long. It took like only a couple hours, and we actually got quite a low loss. So the script that we made actually saves the model every time the validation loss decreases, so that way you're always getting the best model no matter what. And we're fortunate enough to be able to use the NVIDIA 280 Ti graphics card. So as I mentioned earlier, from the testing set, we were able to reach an accuracy of 92%. So we're very happy about that, and that was only with 15 epochs of training. We hope to train it a bit more. It was still converging, but we just ran out of time. So thank you very much for listening. This is our test repo, GitLab repo, if you want to check it out. Thank you.